Hello students, welcome back to today's class on similar triangles. In the previous classes as well as in the lower classes, we learned what are triangles, what are different types of triangles, and we also discussed different congruency rules based on triangles, correct? So we'll try to learn more applications based on the concept similar triangles. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. The first one we're going to discuss is when do you say the triangles are congruent, so that we can apply more applications based on that, okay? So we say not only for triangles, for any polygon, it may be 3-sided figure, 4-sided, 5-sided, 10-sided, but the congruency rule is the same, right? What is that? The two polygons, polygon means any n-sided closed figure. 3-sided we say triangle, 4-sided we say quadrilateral, 5-sided we say polygon, right? In that way, okay? The two polygons with same number of sides, are congruent if their corresponding angles, okay? If their corresponding angles are equal and corresponding sides are equal. So when to say two figures are congruent, first of all, for the same number of sides, you cannot compare a 3-sided polygon to be congruent with a 4-sided polygon. No, that's basically wrong. You can compare a 3-sided polygon with 3-sided polygon only. For a triangle with a triangle only. A quadrilateral with quadrilateral, you cannot compare congruency rules with triangle and a quadrilateral. That's wrong. That's entirely wrong. Right? So when we can say, when the number of sides are same, and if their corresponding angles and the corresponding sides are equal, we can say that these two figures are congruent. Right? A polygon in which all the sides and angles are equal is called a regular polygon. What is that? A polygon in which all the sides and angles are equal. So we have one triangle, we have one polygon. Let's say simply triangle. We say when all the three sides or three angles are equal, we say it is an equilateral triangle, which is nothing but a regular polygon of three sides. Regular. Whenever you see this name regular, it states that all the sides and all the angles are equal, and this is a very important point to note. A regular polygon is very useful when we are trying to bring some similarities between the figures. Right? Let's understand more about the similar triangles concept. All congruent triangles are similar, but all similar triangles are not congruent. Again, we need to understand a few things here. Okay, all congruent triangles, when we say two triangles are congruent, they are similar. They are definitely similar. You need to understand the difference, right? But all similar triangles are not congruent. Similar, see, if you can see a triangle like this and you see one more triangle similar to that, we can just see it's very similar. But they may or may not be congruent. Congruence is different. Congruence, just now we discussed, all the sides and all the lengths of sides and angles should be equal. They may not be equal. They look like similar, but with different dimensions maybe. Right? But if we say that triangles are congruent, definitely they are similar. Definitely they are similar. The triangles are congruent, they are similar, but not if the triangles are similar, we cannot say that they are incongruent, right? You need to understand the basic difference of similar as well as congruent. Next one. In this session, let us explore on similarity of triangles, and we also discuss about basic proportionality theorem, which is a very important theorem, very important application. Lot of geometrical problems can be framed and can be solved using basic proportionality theorem, and not only in this mathematics, so just on the books, even in the practical life, in many experiments, in many constructions, this basic proportionality theorem is applicable, right? It's a very important and very interesting application. Let's try to understand that. So we have different figures, right? Let's try to understand which all are similar figures. Which all are similar figures, okay? So you can see this is a triangle to triangle. So these two are similar, but I don't know whether they're congruent or not. Are you understanding the difference between the similarity and congruency? To get to conclusion that they are congruent, I need to have more information about their angles and sides. But to say that they are similar, just vision is important enough, okay? These two are similar, right? And these two are similar. It's enough to say that these two are similar. But when we come to congruency of the figures, we need to understand more about the sides and angles. Correct? So all squares are similar. Is that correct? Are all squares similar? Yes, definitely. Squares are similar. I cannot say whether they are congruent or not. As of now, I cannot say they are congruent. They are different sizes, but still they are similar. Understand? Next one. Yes. So she is telling yes, that may be correct. I think all equilateral triangles are also similar, right? Equilateral triangle. This is one equilateral triangle of side 2, 2, 2. I'll have one more triangle of 3, 3, 3. Yes, these two are similar, but I don't know about. We are not talking about congruency. We are not discussing about the congruency. We are discussing about a similarity. They are similar figures. They are similar triangles. Okay. Let's try to understand. Oh, we have something amazing here. What is that? 1 second. We missed something. Right. So we have two figures here. Right. So what is this happening? What is this happening? Tom and Jerry. Right. So what's happening? What happened to this figure? We just magnified. Right. Same figure. We just magnified. Now can you tell me? When we are magnifying, is the same figure being replicated there? Yes, but with different dimensions, correct? So now the question is, are these two similar? Yes, we can say that they are similar. Reduced and enlarged photographs of an object are similar. Yes, if there is a triangle like this, and if you zoom or enlarge and you make that as a bigger one, they are similar, but they are not congruent. Congruency means equal sides and equal angles. These are not equal in sizes. They cannot say about congruency, but they are similar. They are similar. Okay, let's try to understand more about that. Two polygons with the same number of sides are similar. Two polygons with the same number of sides are similar. So now we are not talking about congruency. Now we are discussing about a similarity, similar triangles. Okay, all the corresponding angles are equal. Yes. This is the same thing for congruence also. All the corresponding angles are equal, but about the sides, you need to understand about that. All the lengths of corresponding sides are in the same ratio. They may be equal or may not be equal. I'm not sure that. The side lengths may be equal or may not be, but they are in the same ratio. Same ratio or in proportion. Okay, they are in the same ratio or in proportion. Then we can say that they are similar. Understand? That's the reason if a square is there of, let's say, side 2 centimeters and another square is there of side 3 centimeters, the corresponding side ratio 2:3 remains the same throughout the figure. 2:3, this is 2, this is 3, same, 2:3, again 2:3. So all these are same. That means they are not equal in side, they are not equal in length, but but they are equal in ratios. But they're in equal ratio. That type of figures we say they are unsimilar, but for congruency, definitely the sides should be equal, right? Let's try to understand more about this one. The very next and very important theorem, that is a basic proportionality theorem. In short, sometimes we use like a BPT. Okay, in some books you can see like BPT. It is a basic proportionality theorem. So what is this proportionality theorem about? If a line is drawn parallel to one side of a triangle, we are discussing this theorem with respect to triangle only. If a line is drawn parallel to one side of a triangle, so let us take ABC as a triangle. And we are drawing a line EF parallel to BC. EF parallel to BC, right? One side parallel to the triangle to intersect the other two sides in distinct points E and F. In distinct points E and F, then the other two sides, these two sides are divided in the same ratio. Are divided, that means E divides AB in some specific ratio as equal as F dividing AC. F dividing AC. That means E dividing AB means the ratio AE by EB. The same ratio means AE by EB is equal to AF by FC. Now you may ask me, are these two equal in lengths? No, see, we are talking about similar triangles. We are talking about basic proportionality theorem. The ratios are equal, not the lengths. The lengths may or may not be. We are not sure about that, but the ratios are equal. Ratio of AB is to BB, AE is to EB, and AF by FC. These two are equal, right? This is what about a basic proportionality theorem states that, and there are very beautiful applications based on this concept. Let's try to sort it out. Let's try to understand more about that. Okay. So we have a beautiful application here. We have a triangle ABC. We have a point EF, and we know using basic proportionality theorem, right? Let's try to understand more about this one. 1 second. Yeah. Right. So let's take this as X. I didn't mention that. Let's take it as X. We need to find the value of X. So how to get that? So you can see here in triangle ABC, EF is parallel to BC. EF is parallel to BC. So using basic proportionality theorem, I can say that AE by EB is equal to AF by FC. Is equal to AF by FC. What is AE? AE is 4.5 by EB is 3 is equal to AF. AF is x by FC is 5. X by 5. Right. So can we solve this further? So x is equal to 4.5 into 5 by 3. I remember 3 ones 3 15 times of 45. So 1.5 times of 5. 1.5 times of 4.5. So x is equal to 15. 5 is 75. With the decimal points, that becomes 7.5 centimeters. Okay. So this distance is equal to 7.5 centimeters. So that is how we can use a basic proportionality theorem to get the values of unknown ratios, unknown side lengths. Right. So let's try to have one more application based on that so that you can understand more about it better of that. If EF is parallel to BC, find the value of x. We need to find this value of x. Okay. What to do? Again, the same basic proportionality theorem using BPT, basic proportionality theorem, we can say that AE by EB is equal to AF by FC. And not only this one, sometimes in some books you may also notice another type of ratio, AE by the total AB. AE by AB is equal to AF with the total AC, right? Even in that way, you can use basic proportionality theorem. Both are same. They're in proportions, right? This is a ratio that we are considering as proportion. So AE is 5 by EB. EB is equal to 10. 5 by 10 is equal to AFX by FC 12, right? So can we cancel? X is equal to 12. 5 is 12 into 5 by 10. So 12, 5, 60, 60 by 10. That becomes 6. Okay, x is equal to 6 centimeters. X is equal to 6 centimeters. That is how we can use the basic proportionality theorem. Okay. Next one, let's try to move ahead with the next application. In a triangle PQR, E and F are the points on the sides PQ and PR respectively. Once again, in a triangle PQR, so let's try to draw the triangle PQR. Yeah, we have that. E and F are the points on the sides PQ and PR respectively. Okay. If EF is parallel to QR, and PE is equal to 3.9 centimeters. Okay. So these two are parallel. It is enough to say that we can use the basic proportionality theorem. If these two sides are equal, we can say that basic proportionality theorem can be applied. What else information is given to us? PE is given as 3.9. PE is given as 3.9 centimeters. EQ is equal to 3 centimeters. PF is given as 3.6 centimeters. And we need to find FR. As it is given EF parallel to QR, we can directly apply the basic proportionality theorem. Right. So what is basic proportionality theorem here? PE by PQ is equal to PF by FR. So what is a PE? PE is 3.9 by PQ is 3 plus 3 points. So PQ, not PQ, EQ. Let's define with EQ. Let's keep it as EQ, not exact, not completely, so that we will get FR directly. So EQ is equal to 3 centimeters is equal to PF by 3.6 by FR is x. 3.6 and FR is x. So we can go ahead like this. So can we cancel anything? Okay, let us see that. So x is equal to 3.6 into 3 by 3.9. 3.6 into 3 by 3.9. I think we can cancel with 3. 3 ones and this is 3 1.3 times. So 3.6 by 1.3 or it is like 36 by 13. Right? We can leave it like this, or if you want to more specific value, you can divide that 13 and 36. So 13 2s are 26, 13 3s are 39, 13 2s are 26. We're left with 10 and then we need to keep 0.0. 13 maybe 5 times, 13 5s, 5 3s 15, 5 1s 5 6. We still have 13 maybe 7 times, 7 3s 21, 7 1 7 8 9. So 13 7s are 20 91. We are left with again 9 0. So 13 6, whatever the value is, 78, maybe 13 6 are 78. Right. and still continues. Okay, so we can stop it there. So the other side will be 2.76 centimeters. 2.76 centimeters. Okay, so find the value of FR. 2.76 centimeters. It's an approximate, not exactly. It is an approximate value. Right. So this is how you can use a basic proportionality theorem. Let's move ahead for the next question. In a triangle PQR, E and F are the points on the sides PQ and PR respectively. Okay, so that's the diagram. If EF is parallel to QR, yes, EF is parallel to QR. Given that EF is parallel to QR, so it is enough to say that these two are, basic proportional theorem can be applied. And PE is given as 4 centimeters, PE is given as 4 centimeters, PF is given as 8 centimeters, and RF is given as 9 centimeters, and we need to find QE. Let us take it as X. A very easy, simple approach for basic proportional theorem, right? So once again, using BPT theorem, what we can discuss? Using BPT theorem, we can discuss a PE by EQ is equal to PF by FR. PF by FR, okay. So PE, what is PE? 4. 4 by EQ, 4 by X is equal to PF 8 by FR 9, okay. So 4 by X is equal to 8 by 9. So 4 1s and 4 2s. So X is equal to 9 by 2, which is a 4.5 centimeters, which is a 4.5 centimeters. That is the value of QE. So how to get this one? Using basic proportionality theorem. The basic proportion states that if a line is drawn here, which is parallel to the third side, then it divides in the same equal ratios, okay. That means PE by EQ is equal to PF by FR. A straightforward question. Straightforward theorem, no more complications in that, right? Let's try to discuss one more application, right? We have a diagram. In a triangle PQR, E and F are points on the sides. E and F are the points on the sides. See, this is a triangle. E and F can be actually here also. E and F can be there also. But what happened here? If EF is parallel to QR, PQ is given as 1.28. This complete thing is 1.28. And carefully see here, PR is given as 2.56. And PF is given as 3.6. PF is 3.6. Can that happen? Carefully see here. This PR is 2.56, but not PF. PF is more than that. That means F is a point outside the region of the triangle. Outside the region. So F is no more here. Even E is no more here. So they are outside the triangle. So now you need to completely understand the reverse direction. Right? So this is not the, so QR, this is not the middle line, this is the triangle, right? So PQR, that is a triangle, but EF is that line which is in the extended version, the extension, that is outside. So EF is the extended line, that is the outside line. Now we need to apply the BPT theorem, right? Or basic proportional theorem. The ratios are the same. The application is the same. Let me erase all the unwanted things here, right? So let me write once again what all the information is given to us. PQ is 1.28, correct? PR is 2.56. So PF is equal to PF. The complete PF is equal to 3.6 centimeters. That is very important to be noted. Find the value of PE. So now we need to find the total. This value, let us take it as X. Basic proportional theorem, based on that we can write PQ by the complete PE is equal to PR by PF. So what is PQ? PQ is equal to 1.28 by PE. The complete thing is X is equal to PR is 2.56 by PF. It is 3.6. It is 3.6, correct? Okay. So can we cancel? Maybe with 30, I think we can cancel that with 6. Maybe 6 2's, right? 6 squares, that is 6 into 6 is, that is 6 into 6 into 6, maybe it is 256. But with some decimals we need to take care of. So X is equal to 1.28 into 3.6 by 2.56, right? So let me multiply with 100 by 100. 1.28 into 36 into 10 by 256. So can we cancel 36, 6 I guess, 36 into 6, 6 is 36, 6 is 18, 19, 20, 21. I'm so sorry. With 36 into 6 we are not getting that. 6 is 36, 6 is 18, 19, 20, 26. No, I don't think with this one will get. With maybe 16 or maybe with 4 we can cancel. Whatever it is, just try to solve that and you'll get the answer, okay? So 1.28 into 36 into 10 by 256, if you want to just calculate, it's very simple. More than that, 1.282s are. That's what I'm missing here. 1.28 into 2 times 256, that is more easy to solve. 1.28 2 times 256, so 3.6 by 2 we are left with, which is a 1.8 centimeters, okay? So the value of x is, the total length is 1.8 centimeters. Find PE. PE is 1.8 centimeters, right? So using basic proportional theorem, we have a lot many applications. You can have one more question if you want, right? So just like basic proportional theorem, we have something called converse of basic proportional theorem that we are going to discuss in the coming class, okay? So just the converse, that means converse means the reverse. Reverse of the formula that we have discussed for basic proportional theorem, the same statement will be applicable here, right? So more about this converse of BPT theorem that we are going to discuss in the coming lecture. Thank you so much, friends. Stay tuned to get the next lecture. Thank you.
Yeah. Hello everyone. So now we'll be discussing about a rainbow, formation of a rainbow. And a rainbow is a very beautiful and interesting phenomena. Yes, so we'll be learning about that. So my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, we'll learn about something called as a spectrum. Now a spectrum is just a word given to what? A combination of colors. As you can see, we know about VIBGYOR, right? Violet, indigo, blue, green, yellow, orange, red, VIBGYOR. These are the components of white light. Components of white light. So here look at the definition. The band in the sense it's a combination. It's a continuous combination, right? It's continuous. So the band of the colored components of a light beam is called its spectrum. And this is, as we know, which spectrum are we talking about? We are talking about VIBGYOR, and it is called as visible light spectrum. What is it called as? Visible light spectrum, because these are the colors of light which we can identify. And when I say colors of light, these are the wavelengths of light, right? As we discussed, light is a wave. Every wave has a wavelength. There are different colors because of different wavelengths. So the wavelengths of light which we can identify or which help us in seeing objects is called as what? They are part of what? Visible light spectrum. From violet to red. Complete VIBGYOR is visible light spectrum. Simple. Good? Okay, good. So that's spectrum. And when you look at the rainbow, look at the colors in the rainbow. The colors that are formed, are they VIBGYOR colors? Are they the spectrum colors, the visible light spectrum colors? Yes. Starting from violet, you'll have violet, indigo, blue, green, yellow, orange, red, all of them in the proper order, yes or no? But normally, when do you get VIBGYOR? When do you get that spectrum? The one case that we discussed about is in the case of a prism. In the case of a prism. So when white light is incident on a prism, dispersion occurs, and obviously dispersion and refraction occurs, and ultimately you get what? You get red color at the top, violet color at the bottom. So from violet the order is VIBGYOR, or I can say VIB GYOR. It will be in that order. So, but why is light splitting into different colors? Because white light is passing through a prism. And because different colors have different speeds, different refractive indices, they split. So we need a prism or something similar to a prism which can split light, which can split white light. So when it comes to a rainbow, The question is, who will split white light? And when I say white light, we are talking about sunlight. Sunlight is also white light. It also has all the different colors. So who splits sunlight in the air, in the atmosphere? Do you have prisms in the atmosphere? Glass prism in the atmosphere? We don't. All that we have is air, and air is made up of gases. But there are clouds. It might rain at times. So there are water droplets. There are water droplets in the atmosphere, yes or no? When it rains, what is that? Rain is nothing but water falling down, water droplets falling down. So there are water droplets in the atmosphere. So those water droplets act like what? Act like a prism. So they split white light into these colors. And it's obviously a natural phenomena. We don't do anything. It occurs in the nature, by the nature itself. We do not do anything, so it's a natural phenomena. So if you look at this, a rainbow is a natural spectrum. Natural spectrum appearing in the sky generally after a rain or after a rain shower. Good. And it's caused by dispersion of sunlight. Yes? And remember, which white light are we talking about? Sunlight. So it is caused by dispersion of sunlight by tiny water droplets. So these water droplets act like prism. They act like prism. And where are these water droplets? They are present in the atmosphere. Present in the atmosphere. Clear? That's a rainbow. Okay, let's continue. Let's learn about that in much more detail. So here look at this. Let's say we take a water droplet, almost a sphere. Okay. So let's say sunlight. Okay, which light are we talking about? Sunlight is incident on a water droplet in this way. And that sunlight, we'll take it as white light. Sunlight is white light. Then here, look at this. It is going from which medium to which medium? It is going from air to glass. Sorry, not glass, my mistake. It is going from air to water because we are talking about rainbow. So it is what? A water droplet. So it is going from air to water. So it is going from which medium to which medium? A rarer medium to a denser medium. Obviously, refraction is going to take place. But at the same time, dispersion also will take place. Because here this act like a prism, next a different media. And the speeds of different colors in water are different. That is the reason why dispersion occurs as well as refraction. Both the phenomena occurs. Dispersion as well as refraction. And if you want to know what is the normal, first of all, look at this. This is like a circle, right? So center will be somewhere here. And it's exactly a sphere. In a sphere, normal passes through what? Normal passes through the center of curvature. So this is something like the normal. Got it? This is like what? Like a normal. And as you can clearly see, the rays are bending towards the normal because it is going from rarer medium to denser medium. So refraction is correct. And at the same time, dispersion also occurs. So dispersion took place. Then when the light, when the light rays, now at the second surface, the second surface they come across is between water and air. Between water and air. And understand this, at every surface, both reflection and refraction take place, both of them. But when it comes to opaque surfaces, mostly reflection takes place. When it comes to transparent surface, transparent media, mostly refraction. But both of them take place. So here it is water to air. Some light will go outside, but some light will come inside also. Some light will come inside also. It undergoes what? It undergoes reflection here. So at the first surface, it underwent dispersion and refraction. Now the second time, it is undergoing reflection. Which phenomena are we talking about? Reflection. We call that as internal reflection because it is taking place inside itself. And then again the third surface. Now it is going again from water to air. Now we are mostly concerned with the light that will be coming out right? And this light will be coming out. Got it? Okay. So these are the processes that happen. Okay, this is sunlight. And if you go into all the processes, all the phenomena of light that occur here, the first one, dispersion and refraction. The second one, we are concerned with reflection only. So we call it as internal reflection because it takes place inside the same medium. And again we come across what? Refraction. So three phenomena occur. 1, 2, 3. Got it? Good. So, and as you can see at the end, at the emerging side, there are different colors. You have violet color at the top and red color at the bottom. So if there is someone here, that observer should be able to see both the lights. But the issue is, there is one issue. Here, how many drops are we talking about? Only one drop. But the question is one drop enough to form a rainbow? Imagine the size of a rainbow. Rainbow is big. A drop is very small. So is one drop enough to form a rainbow? That's the question. We'll discuss about it later on. Okay. Just keep it aside. So as you can clearly see, these are the factors that we need for the formation of a rainbow. Obviously, if you want to look at a rainbow, you have to be there. So observer should be there. Okay? Because light is not something tangible. You cannot touch light. You can only see it. We can see it through our eyes. So we need an observer to be there. Okay, then that aside, obviously we need a sun. Why do we need sun for a rainbow? Because the first thing on a water droplet, sunlight should be incident, yes or no? Look at this. Sunlight should be incident. Sunlight comes from the sun should be there. And look at the observer. Where should the sun be? Sun should be behind the observer, back of the observer. If I am like this, behind me sun should be there. And in front of me somewhere, there should be rain droplets or water droplets. There should be water droplets. Okay. So a rainbow is always formed in a direction opposite to that of the sun. Right. This is the sun behind us, whereas rainbow is in front of us. Rainbow is in front of us. And wherever rainbow occurs, we need water droplets. Water droplets should be there. Now from where do we get water droplets? We get water droplets from rain, or you can think of it as fog or any other precipitation. But we need a source of water droplet. Mostly rain, but it could be anything else also. Good. Okay. So summary of whatever we discussed here. The following phenomenon are involved in the formation of a rainbow. What are they? First, refraction is involved, dispersion is involved, and reflection is involved. Those three take place. At the same time, for a rainbow to be formed, the sun should be behind the observer. Discussed, yes. So the sun should be behind the observer, and rain or any other source of water droplets should be in front of the observer. These are the things that are required. Okay, these are the conditions and these are the phenomena that take place. Refraction, dispersion, reflection. All three of them take place. Got it? Okay, good. So we understood how rainbow is formed. We understood what are the conditions required, the sun and the rain. Sun should be behind, rain should be in front of us. Clear? Good. Now, there is an interesting question. The question that we postponed, now it is here. Is a single raindrop enough to form a rainbow? What do you think? Yes or no? Is one single raindrop enough to form a rainbow? Think about it. Is one single raindrop enough to form a rainbow? And the answer is no. Think about the size of a raindrop. A raindrop will be very small. Whereas when you look at the rainbow, the size of a rainbow will be huge when compared to the size of a raindrop. Yes, rainbow would be something like this, big. But a drop will be only small, this much. How can a single drop form a rainbow? Not possible. Then how is a rainbow formed? A rainbow is formed because of many drops. So here if I have this as a rainbow, let's say this is a rainbow. for example's sake. Right, and this is us. So here, or wherever the rainbow is, wherever we see the rainbow, there are many drops there, not one drop, there are many. And every drop splits the light. Every drop splits the light. Okay, at the top generally you have red, at the bottom you have violet. That means at the top if you are seeing red color, so that means from the top which color of light is coming to us? Red color is coming to us. Whereas from the bottom, or at the bottom if you can see violet color, that means from the bottom which color is coming to us? Violet color is coming to us. So one drop is not sufficient. We need multiple drops. There will be many drops wherever the rainbow occurs. From one drop you get one color. Right. So generally from the top you get red color. From the bottom you get violet color. So one drop is not at all sufficient. We need many drops. We need many drops. So look at this. The raindrops at the top of the rainbow appear red because only the red light rays from them enter our eyes. Whereas the raindrops at the bottom appear violet because only violet rays from these or from those enter our eyes. As simple as that. Got it? If you are seeing any color, if you are looking at any object, and if its color is red, that means red color is coming to us. If its color is blue, blue color is coming to us. If its color is orange, orange color is coming to us. In that way. Got it? Good. I'll show you another interesting thing here. See here. Red color and violet color. Red end we get red color, violet end we get violet color. Simple. Now I'm thinking, sir, from one raindrop also we get both the colors. Yes, but that raindrop will be very far away. So when you look at the color of light that come, see that here. Let's say this is violet, this is red. Now near the raindrop, the distance between them is small. But as you can see, as the rays travel, the distance between them keeps on increasing. The distance between them keeps on increasing, yes or no? Yes, so that means if there is an observer here, and see, look at this, our eye is very small, only this much, right? This much. That's it. So in this much space, how much light will enter? Right? Only some part of light will enter, but the raindrop is very, very far away. So in this case, only red light is entering the person, the other light will not enter the eye of the person, will not. So from one raindrop, you can only see one part of the spectrum, only one color. That's it. You cannot see all the colors. So one raindrop, rainbow formation, no. You need multiple raindrops. You need many. You need many raindrops. So from the top you have raindrops. Throughout the rainbow you have raindrops. It's like that. Understood? Good. Okay. Now another interesting question for us. Now when we look at the rainbow, if I ask you what is the shape of rainbow, what will you tell? Sir, semicircle. A half ring. Half ring is the shape of a rainbow that we can see from the ground. But if you observe a rainbow from an airplane, and that airplane is flying high in the sky, what shape would you observe? What shape would you observe? And you have few options A, B, C and D. A, semicircle, C, circle, B, circle, C, spherical and D, none of the above. So which shape do you observe? Interesting question, right? And the shape that you observe will be a circle, not a semicircle, when you see from high up above. In an airplane that is flying high, there you see a circle, but on the ground On the ground we see what? We see a half ring, semicircle. Why? Why is it? See, this is the aeroplane. If you are here, this is the ground. So you are high up. Then you can easily see what? You can easily see a full rainbow. You can easily see what? You can easily see a full rainbow that is a circle. Okay. But if you are on the ground, then see, you can only see the top. You can only see until here. That's it. This part, if light tries to come, no, it cannot come. Ground will block it. Ground will block it, right? So there are two cases. One observer is in air, high up in air. The other person is on ground. So for the person on the ground, the rainbow will appear only as a half ring. Whatever he can see above the ground. Whereas for a person in air, he can see completely. That's why it is a circle. Got it? Good. So you can see here, a rainbow is actually circular in shape, but the bottom half is not visible. We cannot see it from the ground due to the horizon. Horizon in the sense the level of the ground, the horizontal level of ground. And this horizon is responsible for many things. Let me give an example. Let's say this is Earth. Okay, let's say this is Earth. There's a point here, then the horizontal level there, the tangent drawn there, the tangential surface is what is horizon. Now why is this important? If there is any person here, above the horizon, if anything is there, it will be visible. Below the horizon, if anything is there, it will not be visible. Simple example. If I take an object here, from that object, light should reach the observer. See that? If you draw a straight line, obviously light travels along a straight line, that is the reason. See what happens. It gets blocked by Earth. It gets blocked by Earth here, so it cannot. This object will not be visible. Right? So, you can say above the horizon it is visible, below the horizon it is not visible. Okay? Obviously from the ground. That is the reason why we can only see half of this rainbow. We can only see a semicircular ring as rainbow from the ground. Who blocks it? The horizon blocks it. Got it? Good. So next question for us. Which of the following phenomena of light are involved in the formation of a rainbow? What is the answer going to be, everyone? Very quick answer, very simple. Which of them are involved in the formation of a rainbow? Reflection, refraction, dispersion, or all of the above? And the answer is option D, all the above phenomena are involved. Reflection is involved, yes. Refraction is involved, yes. Dispersion is involved, yes. All of them. Good. So it's practice time now. We'll go into a few questions because we have time remaining. Let's go into a few questions, mostly regarding dispersion. We learned about rainbow, so we'll go into a few questions regarding dispersion so that it will be a revision and so that you'll understand dispersion much more clearly. So very simple question we'll be starting with right from the basics. We'll be going in an order. So which color of light among VIBGYOR deviates the most through a prism? You have two options. I have only given two options, the extreme colors red and violet. So which of them deviates the most? Red or violet? Everyone, quick. You have to remember it. You have to remember the diagram. So when you draw the diagram, you should be able to tell. Which deviates the most? Red or violet? And the answer is violet. Yes or no? If this is a prism, this is white light. That means all the colors have the same angle of incidence. Then they get refracted, something like this. And then like this. And what is the order? Red is at the top, violet is at the bottom. So if you look at the angles of deviation, Obviously here you can clearly see that angle of deviation of violet is greater than angle of deviation of red. So which color deviates the most? Violet color deviates the most. Got it? Good. Next. Another interesting question. Which color of light among VIBGYOR again has the highest refractive index? Has the highest refractive index in glass? Because when we talk about a prism, we generally talk about glass. So which of them has the highest refractive index in glass? You can again take the example of a prism and try answering this. Which of them has the highest refractive index? And the answer is violet. Now why? It's very simple. Whichever deviates the most, greater the deviation through a prism, greater is the refractive index. Greater the refractive index. Is that clear? And as we have seen, violet deviates the most. Which color deviates the most? Violet deviates the most. So violet has the highest refractive index. So you can also write that point. I'm giving questions in an order so that you can easily remember them. Violet deviates the most. Violet deviates the most and hence has the highest refractive index. Has the highest refractive index. Is that clear? Right? You have to remember these points, the logical reasoning, okay? There is a logic behind them and you have to remember them. Understand and then remember, okay? Obviously, you have to understand them. That's the most important one. Then also remember them, okay? Good. Next. Another interesting question. Which color of light among VIBGYOR again has the highest speed in glass? Which color of light among VIBGYOR has the highest speed in glass? Now we got the relation between refractive index. Now using refractive index, you should be able to tell which of them has the highest speed. So please tell everyone, red, violet, blue or all the colors have equal speed. Let's say not in vacuum. I'll just say all the colors have equal speed. I'll just leave it there. So A, B, C and D. So please tell. Which of them has the highest speed? I'll give you some time to think. 15 seconds. Think about that. 15 seconds. And the answer is red color. And the answer is what? Answer is red. Now how come it is red? I'll explain. See here. We know that the information that we know until now is the deviation of violet light is greater than deviation of red light. Then the refractive index of violet is greater than refractive index of red. These are the 2 points that we understood. But we know that refractive index is equal to C by V. That means refractive index is inversely proportional to V, speed. Right? Refractive index in the numerator, speed in the denominator. That means they are inversely proportional. So you can say lower the refractive index, greater the speed. Inversely proportional will mean this. If one is less, the other will be greater. So if you need highest speed, you have to look at the lowest refractive index. Who has the lowest refractive index? Red. So you can say speed of violet is less than speed of red. It inverses. It becomes ulta. It becomes ulta. Clear? Speed of violet is less than speed of red. So you have deviation, refractive index and speed, relation between them. So here which has the lowest speed? Violet. Highest speed? Red. I'll say lowest speed is violet. Again, obviously, we are discussing among the VIBGYOR. Lowest speed in glass. I have to be specific. And red is highest speed in glass. Got it? Good. And hence the answer is what? The answer is red. Red has the highest speed in glass. Interesting. Now another such interesting question. In fact, almost similar. Which color of light among VIBGYOR has the highest speed in vacuum? Now we are talking about vacuum and we have few options. Which of them has the highest speed in vacuum? In glass, the highest speed is for red color, but here in vacuum, who will have the highest speed? Red, violet, blue, or all the colors have equal speed in vacuum? What is the correct answer? Again, I'll give you 10 seconds. Very simple, straightforward question. Yeah? Time is up and the correct answer is D. Remember this point, this is a very important point. In vacuum, all the colors will have equal speed. Every color will have equal speed. Vacuum. In vacuum, speed of every color is the same. And how much is that equal to? It is equal to C, and that is equal to 3 into 10 power 8 meter per second. All of them have the same speed only in vacuum and also in air also. Air and vacuum almost the same when it comes to refractive index. Okay, good. Now next question. Which color of light among VIBGYOR has the longest wavelength? This is something which you have to remember. So which of them has the longest wavelength? Red or violet? Something that you have to remember. So 10 seconds. Red or violet? Which of them has the longest wavelength? And the answer is red color. That's it. Remember it. Okay, it's a simple remembering point. Wavelength of red is greater than wavelength of violet. And again, if you want how, you can think, we can start from here. Deviation of violet is greater than deviation of red. That means refractive index of violet is greater than refractive index of red. But again, refractive index and wavelength are inversely proportional. Understand this. So greater the refractive index, greater the wavelength. So you can say this will become ulta. Violet light will have least wavelength, red light will have greater wavelength. Even in terms of speed, it is the same. So mu is inversely proportional to lambda, mu is inversely proportional to speed. Got it? Good. So and hence the answer is what? Red color. And that's it everyone. We learned about rainbow and we went into a few questions regarding dispersion also. Thank you.